Okay, so the next thing I have to talk to you about is the solubility chart. So the solubility chart, again, is in your data booklet. And the solubility chart is on page 10. Okay, so it looks just like this, which is exactly what it looks like there on the slide. Now, how you use a solubility chart? Well, what does solubility mean? Solubility essentially means will it dissolve in water? Okay, if it is soluble, it's on the top. Okay, it says AQ afterwards, which means aqueous, which means it can dissolve in water. If it doesn't dissolve in water, it's the bottom there, and it will stay a solid in water. Okay, now why is this important? Well, it's important as we move on in this course for voltaic cells, which it'll come very obvious to you that it's super important. But how I use this chart is I essentially find my anion on the top, okay, or my negative on the top. Then I'm going to go down and I'm going to see kind of what most do and what the exceptions are, okay? So in the beginning here, most of these compounds are soluble. There are some exceptions. So if my exception is there, then it's unsoluble. But if it's not there in the bottom, then whatever compound it is soluble. Okay, and the same deal, but opposite on the other side. So solubility greater than or equal to. So in the last three here, the top part, those are the exceptions that are soluble. Most of them are not soluble. Okay, so it's important that we know how to use this and we know which ones will be soluble or will like dissolve in water and which ones won't. Okay, which ones will stay solid. That just really means, so if something is soluble, it means that water is able to break those bonds apart and they become free floating ions. If they are insoluble, they'll stay as a solid, and that just means that water is not strong enough to break those bonds apart.